The channel not only explains technology, it designs the future. If you want AI, data science, and real-world tech mastery, welcome to Technical Professor.
Hey everyone, welcome back to Technical Professor. So in this lecture, we are going to discuss about what is linear algebra for ML. And don't worry, this will be not boring lectures like your college lectures. And this lecture make you industry ready and help you how Netflix do recommendation and how Google use linear algebra and how it what we will what we are typing in Google keyboard and what we will type next. So grab a coffee. This is going to be fun. So let's start it. So let's start it. So why linear algebra is essential? So linear algebra is essentially for data representation and enabling efficient model computation and optimization. It provides the foundation for understanding relationship with data, and it is crucial for effective machine learning algorithms. So data is stored. How data is stored? And data is stored using vector and matrices. So let's say very clearly, if if car if machine learning were a car, and then what is the linear algebra there? Linear algebra will be engine. Because why? Data is stored using vectors and matrices, and models calculated prediction using matrix multiplication, and neural networks are just layers of linear algebra. So when there will be no linear algebra, so there will be no ML period. So let's learn about. That's fine. So scalars, vectors, and matrices. So let's warm up with basics. So scalars, vectors, matrices. Scalar is just a number, like think temperature, like temperature equals to 30 degrees Celsius. It will be scalar, just one number. And what is vector? Vectors are like a list of numbers, like profile, age, and salary and experience. What is matrix? Matrix is a table of numbers like Excel sheet. So ML loves Excel sheets. Okay. And so in real life examples, carry a single numerical number value. Value that is representing magnitude. So in machine learning, scalars are essential for computation, like weights in models help to quantify relationship between data points. All right. So if salary equals to 50,000, that is a scalar. Like now, another example, let's learning rate equals to 0.01. It's also a scalar. So scalar controls how fast model learn. And so yes, even small numbers also can be powerful. All right. So let's learn about vectors. What are vectors? Imagine you are applying for a job. So your profile become vector. So vectors are fundamentally in machine learning and representing features in data sets. and their notation signify directions and magnitude and essential for computation, algorithm, and data representation. So your profile will become vector. For example, age, skills, and experience. So ML does not see you, it sees numbers. So congratulations, you are officially a vector. All right. So now learn vector geometry. So vector not just numbers, they have direction and magnitude. Okay. So think of Google Maps direction. There will be North Pole, South Pole, and West, East. This is direction. Where are you going? And magnitude, how far you are going. Okay. So ML uses idea to understand similarity between data points. Okay. So let's learn about dot product. Let's learn about vectors operations. So adding vector is like a combination combining skill A plus skill B. It will be better. Okay. Like scalar multiplication. That's like saying this feature is very important. That is multiply by 10. Okay. So vector addition combine multiply vector into single resulting vector, while scalar multiplication scales a vector by constant. So providing essential tool for manipulating data in machine learning. Okay. So let's learn about dot product. So dot product is a fundamental operation that combines two vectors reading a scalar value. It represents the geometric relationship between them. It is crucial for many machine learning applications. So, like, I will explain it using, okay, example x equals to 2 and 3, and w equals to 4 and 5. I have to do dot product. How we will do? X or w. We will do 2 multiplied by 4. That is, we will multiply with weight of x and w. Then we will multiply 3 with 5. What will be this? 23. 8 plus 15. Okay. So this single operation is used to make predictions, neuron outputs, and train models. So what we can say? Dot product. What is this? It will be ML heartbeat. Okay. So let's understand what is cosine similarity. Cosine similarity checks how similar two vectors are. Okay. So that's how Spotify suggests songs and Netflix recommendation movies. Spotify suggested songs and Netflix recommendation movies. LinkedIn suggest connections. So ML will ask how similar are those two people. So let's learn about. So cosine similarity measures the angle between two vectors in multi-dimensional space. It ranges from -1 to 1, and it provides an intuitive understanding of their similarity and relevance in machine learning context. Okay. So let's learn what are matrices in machine learning. So matrices are essential for data representation machine learning. They allow us to organize and manipulate data set efficiently, enabling effective computations and model training process across various applications. So now imagine 1000 users. Each user is a vector. So stack them together, boom, you get a matrix. So what are rows there? Users, like them, like there are 1000 users. What are rows there? Users. And what is column? Features. This is your data set. Okay. What is definition there? Matrices are essential for representation in machine learning. These allow us to organize and manipulate data set efficiently. So it is enabling effective computation and model training process across various applications. Let's learn matrix operation. So matrix addition is simple, but matrix multiplication that where magic happens. But don't worry, libraries like NumPy do the heavy lifting for us. Okay, that's on matrix multiplication. So column of first matrix equal to rows of second matrix. The number of column first matrix multiplied with the number of rows in second matrix. That is ensure valid dimensionality. If shapes doesn't match, ML says sorry bro, dimension mismatch. Okay. So what are rules of matrix multiplication in ML? So y equals to x into w. So what is x there? X is input data. What is w there? That is weights. And what is y? That is predictions. Alright, so this equation is repeated millions of times during training. Alright, so what is identity and transpose? So multiplying with anything by 1, that is nothing changes, that is identity. And it is like number 1. And transpose it flip rows into columns. Okay, like 5, 10. What is transpose of this? Alright, it is used everywhere, especially in optimization. Alright, what is inverse matrix? So inverse matrix is like division, but not all matrices have an inverse. ML often avoid inverse because it's expensive, it's unstable, and smart ML use alternatives. Okay, so what a system of linear equation like x equals to b. So in base, it is basically find the best x that fits the data. So linear regression is just solving this smartly. Okay. So what is rank of matrix? So rank tells us how much real information is inside data, whether features are redundant or not. And low rank equals to duplicate information. And ML hates useless features. So what is linear transformation? So linear transformation map input vector to output vector, it maintaining a vector space structure. And this concept is essential in machine learning models, that is enabling effective data manipulation and feature extraction. So linear transformations studies rotates or squares data. So imagine squeezing a sponge, that's transformation. And neural network do this by layer. So what are eigenvalues and eigenvectors? So it is big name but simple data. Eigenvectors goes two important directions, and eigenvalues are how important they are. So PCA used these two, that is principal component analysis. It is used to reduce dimension, keep important info, and remove noise. All right. So what are eigenvectors in ML? So PCA says I have already said that is full form principal component analysis. Let's keep what matter and throw away the rest. That do the eigenvectors. It keep important part, but through just materials. That is smart ML, not brute force. What is norms in machine learning? So norms means distance, like L1, Manhattan distance, L2, straight line distance. It is used in regularization, KNN, and optimization. So norms in machine learning. So norm help, it is help to prevent overfitting. Okay, and they will tell little models don't overreact, stay calm. Okay, so let's a practical example. So linear regression foundational machine learning technique used for predicting continuous outcome. It utilizes linear relationship between variables to optimize prediction effectively. So like y equals to wx plus b. This is pure linear algebra. So training equals to finding best w and b. So what are common mistakes for beginners? So avoid pitfall in ML maths, and understanding shape mismatch and tendency to overthink mathematical concepts are crucial. But recognizing these mistakes can streamline your learning process and enhance your confidence in linear algebra applications. Okay, so you can ignoring mistakes are ignoring matrix shapes and fear of math, memorizing instead of understanding. Don't memorize anything, just understand everything. That's good line. Don't memorize anything, but understand everything. So remember, ML math is logic with numbers. It's not torture. All right. So what is summary today? What is so let's in this lecture we are explore fundamental concepts of linear algebra that is essential for maths and machine learning. So next we will delve into what of probability for improved ML understanding. So let's summarize the today lecture. So data equals to, and it's not good. Data equals to vectors and data set equals to matrix and prediction. It is matrix multiplication. So linear algebra is everywhere in ML. Next lecture will be probability for machine learning. This is where Modana do very confident. So if linear algebra feel clear now, smash the like button, comment probability for the next lecture. See you in the next one. Thank you so much for watch this video.